Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 Problem of the Week video, and this one is about probability and also parity, which is the oddness or evenness of a number. So without further ado, let's get on with the video. This is AMC 12A, Problem 12 from the year 2007. Integers A, B, C, and D, not necessarily distinct, are chosen independently and at random from 0 to 2007 inclusive. What is the probability that AD minus BC is even? And here are your answer choices. So looking at the keywords, we can see that it tells you 4 integers, and then they aren't necessarily distinct, so that means they could be the same number. They're chosen independently from 0 to 2007. And it is asking you what is the probability that AD minus BC is even. So how can the difference of two numbers be even? Well, we can see that an odd number minus an even number is equal to an odd number. So for example, 3 minus 2 is equal to 1, which is an odd number. And then odd number minus odd number, for example, 3 minus 1 is 2, which is an even number. And then an even number minus an even number, which, for example, 4 minus 2 is 2, so that is an even number. So it can either be an odd number minus an odd number or an even number minus an even number. Now, the two numbers are AD and BC, so that is a product of two numbers. So how can a product of two numbers be even? Well, we know that an odd number times an odd number is an odd number. For example, 1 times 3 is 3. And then an odd number times an even number, for example, 1 times 2 is 2, which is an even number. And then an even number times an even number, for example, 2 times 4 is 8. That is also an even number. So there are two cases for which this can be. So the first case is an odd number minus an odd number, from right here. And then the second case is an even number minus an even number. So when does these two cases happen? Well, for the first case, how can a number be an odd number? Well, there is only one way. That is if the two numbers are odd. So the probability that we get an odd number from 0 to 2007 are a total of 2008 numbers. So divided that by 2, you get 1004 over 2008. Is a possibility that you get one odd number. So this is equal to 1/2. So the possibility that you get one number is 1/2, and then times the other one is 1/2. So that is the possibility that you get an odd number for this one. And then so what is the possibility that you can get an odd number for the second number as well? That you multiply it by 1/2 and 1/2. So for case 1, it is going to be 1 over 16. Now for the second case, this is a little harder because to get an even number, we can either have an odd number times an even number or an even number times an even number. So this is supposed to be AD minus BC. So the chances of AD being an even number, it can be A is even, D is odd for this scenario, or it can be that A is even, D is even for the second scenario, or it can be that A is odd and then D is even for this scenario as well. So these two are from this first scenario, and this scenario is from the second scenario. So what is the probability that A is even? That is also going to be 1/2. And then D is odd is also going to be 1/2, because since this is choosing it independently, we can have the same number used twice. So this is the same for the other three. So these three cases, this is going to be added together since it is all talking about this one thing. So this is going to be 3/4. And then so the second possibility that it's going to be even is also going to be 3/4. For this case 2, it's going to be 9 over 16. Now we just have to add case 1 and case 2 together. So 9 over 16 plus 1 over 16. This is going to be 10 over 16, which simplifies down to 5 over 8. Looking at the answer choices, we can see that the answer would be E, 5 over 8.